Everyone, welcome to our next session. It's with Manali. Manali is a product line manager at Nokia, where she drives the SD-WAN security and network services product portfolio at Nuage Networks at Nokia company. Welcome, Manali.
Thanks, Sukrita. Thank you for the introduction, and thank you everyone for joining this presentation. As Sukrita mentioned, my name is Manali, and I work as a senior product manager with Nokia in areas of network security, network services, and scale. Security is a hot area with a lot of scope for innovation and opportunities. And security has a lot of branches too, like, there is network security, cloud security, a lot of aspects like human element. But today I will be focusing mostly on securing the fundamental software development cycle. So, whether you are building a security product like firewall, or whether you're building any web cloud based application, securing the software development cycle will help you reduce many vulnerabilities in your product at lower cost. Again, just a reminder that I'm not talking on behalf of Nokia, but whatever I'll be sharing is based on my learnings that has been so far. Yeah, and in terms of the agenda in today's presentation, I will provide an overview of the current security landscape. I'll also share the importance of securing your SDLC. I will talk about the security challenges and issues we see without a secure SDLC. I will also talk about how vulnerabilities are discovered, how are they assessed, how are they remediated, what they look like, and how AI can potentially help resolve some of the challenges that we see with vulnerability and threat management. Finally, I will talk about new challenges to security via quantum computing and AI that you're already aware of. And then I will close the session with jobs and then also some security certification. So I hope that this presentation gives you information to continue, or if you are already in the security journey, continue it, or to just start your security journey. Okay. Then let's get started. The about me, I think I just spoke about it a bit, but yes, so with my experience, I did start as a software developer. Then I moved into more system solutions, realized that I wanted to do more customer focused roles. So I did take pre sales, and now I work on product management. And outside of my work, I do enjoy women empowerment initiatives. So I do take part in Tech Women, and then also I take part or even chair a couple of initiatives at my work. If you're interested in connecting to me and knowing more about me, I have put in my QR code, and you can find me at Manali Rane on LinkedIn. Okay. So, how does our security landscape looks like? You all might be aware of the security. You might be hearing in news, different security vulnerabilities, security threats being released every year and every day. So, 2023 almost saw a 72% increase in data breaches compared to 2021. The denial of service attacks that are present, they have also increased by almost 85%. Previously, vulnerabilities were discovered, but exploiting those vulnerabilities were difficult. But now you see that exploiting those vulnerabilities have also increased almost by 55%, right? It was seen that almost 65% of these vulnerabilities that were discovered were predominantly seen as flaws during coding or development. And that doesn't mean to, everybody does the best of coding, but usually that we've seen that almost 65% of vulnerabilities were discovered during coding development stages, and that is something that we can avoid. For example, if you look at the SQL injection, which is not validating the input, or is looking at the input validation, SQL injection was reported as the most, or one of the critical vulnerabilities with an exploit probability of more than 9%, or it's regraded from a score of 1 to 10, so 9 is high. So, but what does that mean, right? This means that there are opportunities. So, the US labor law, or the US Bureau of Labor, indicates that cybersecurity jobs will grow almost from up to 32%. So, there is definitely a lot of interest in this area, and there are definitely a lot of opportunities also in this area. Um, So let's look at the software development cycle, right? You guys must be aware of the software development cycle. But currently, this is the current software development cycle. You go in the cyclic form, you start from requirements and then you go to design, development, and to maintenance. But mostly, security is not considered as a part of this software development cycle. Security is usually an afterthought. So whether you're collecting requirements from the customers, even there is a bit of lack of customer awareness, so you do not include requirements, use cases, security use cases when you're looking at requirements. Similarly, you're not discussing, compliance, or security is not typically embedded in your analysis also. Even when you're designing, and you might be supporting third party components, or you might be having old outdated packages, you might be having open source vulnerabilities, unauthorized access. So security is typically not even built in during your design phases, right? What that results in during the development, you might have some issues that are discovered. So based on OWASP, which is an open source organization, they talk about top 10 known exploits and vulnerabilities that were found, or they published that list. And those top 10 typically point out to improper input validation, like an SQL injection, buffer overflow, or use after free, these kind of vulnerabilities. Similarly, if you don't have testing, then you don't know if you have any open ports, if you have any unsupported vulnerable versions, if you are using any deprecated ciphers, or if there is actually a way to potentially attack, via denial of service. You don't know if there is a vulnerability, how much information have you been able to log. So this also results in unsupported config, difficulty to do security patches, and then eventually when customer runs, when the product is deployed, and then when customer runs their own test, then you are bombarded with a set of vulnerabilities. So at that point, the cost to fix those vulnerabilities is usually very high. You run into SLA misses, and it becomes very difficult to contain the situation. So, an alternative approach to that is, and that is something that is recommended, is that you embed security entirely within your software development cycle. So, basically, you start with risk assessment. You identify what your assets are, you identify what your risk factors are. If you have to, there are audits, there are compliance, there is common certification. You start very early on identifying what your risk factors, your assessment is. Once that assessment is done, then you start looking at a threat and analysis model. Say, for example, um, I work on the data center product. If some of my elements are out in the internet, some of them are within the data center, some of them are already deployed in the cloud. I take a complete hold of what my assets looks like, what are their attack surfaces, how exposed they are, and based on that, I come up with the threat and risk analysis. I put together some design principles. I like least privileges. Only anybody who wants to be authorized gets the authority. Not everyone is authorized by default. um, so those are the items that I think about during the design phase. During the development phase, I start thinking about software composition analysis. There are a lot of tools that can help you do your software composition analysis. There are tools that can help identify the versions that you are using, whether they are outdated. There are the OWASP organization. Not only the OWASP organization, there are other organizations too. Those organizations will they provide secure coding guidelines. So you can take into consideration those secure coding guidelines when you're actually developing your product. The software bill of material, the SBOM, helps you to actually identify what are your interdependencies. So if you update a certain package, what is the impact of that package on other packages? So it helps you identify those interdependencies. And then if you can actually embed the entire security process within your CI/CD with white box testing, you can actually get alerts sooner than what you were getting without any security testing. The security testing part itself again adds a lot of value. So you have a lot of vulnerability scanners. There is Nessus is one, there is Scholars, but there are a lot of other vulnerability scanners too. They help identify your package, and then they compare your package, or like evaluate your package with all the vulnerabilities that are present. Then you have Nmaps, which can also help with your port scanning. There is web scanning, fuzz testing. These tools actually help you to identify vulnerabilities that are present on your web applications. And then there are ethical hacking tools that you can actually use to hack you into your elements. You can mimic what an hacker would do. So these kind of activities, like security testing, also helps you identify vulnerabilities. And then whatever you have learned during your development and testing phase, you can either put up a document around it. You can update your ciphers, you can update your cryptographic algorithm, or you can harden documents, right? So for example, if you have discovered certain ports that should have not been exposed to the customers, you can block those ports. If it's not possible for you to block the port, you can ask the customer to via the hardening steps to block these ports. So with all, like basically embedding security in your development cycle, you, as you can see, you are discovering threats and vulnerabilities very early on, right, as compared to what it was in the previous, without the security embedded into the cycle. So then once you have discovered vulnerabilities, you assess them, you prioritize them, and you remediate them, right? You provide security patches as needed. But what do these vulnerabilities look like, right? I've given some summary over here. It's typically in this format, which is CVE a year, but let's see what they actually look like. A typical vulnerability will come in the format, which is a CVE, then the year, and then actually a vulnerability that is present. This is the National Vulnerability Database. This information is publicly available. Anytime a vulnerability is being released on the NVD database, you will get the information of that particular vulnerability. So, for example, SSH. You guys might be using SSH, right? Maybe you're aware of SSH. So recently, I mean, in 2023, a vulnerability was discovered in SSH. The way these vulnerabilities work is NVD will give you a base score. This base scoring goes from critical to low. How is the score calculated? The score is calculated based on multiple inputs. So it takes into consideration attack vector. Can this vulnerability be exploited remotely, or does it need a local intrusion to attack the vector? What is the attack complexity? Is it very difficult to actually attack that vulnerability, or is it very easy to exploit the vulnerability? If it's very easy to exploit the vulnerability, then the score goes high. What are the privileges required? Is it restricted? Do you need to have an authentication or a username and a password? Or without username and password also you can exploit this vulnerability? Does it require a user interaction? So does it require for you to actually click the link, or does it, like, it doesn't, as long it's downloaded, it can do what the nasty things that it is required to do? So based on, and then of course there is this security triad, right, which is the confidentiality, integrity, and availability. What is the impact of this particular vulnerability on those aspects? So based on these factors, you come up with a base score. It might happen in this case the base score is medium, but it might happen that the base score is critical. So what do you do now? Do you go ahead and tell your customers that, hey, we have discovered a critical vulnerability and it impacts everybody? No, not really. The base score is just a starting point for you to understand that this particular vulnerability has so and so factors. We have evaluated these factors. The NVD has evaluated these factors, and that is the starting point. But in order for you to calculate the expert score, there are two other parameters that you need to take into consideration. One is the temporal group metrics, which actually talk about whether this particular vulnerability is exploited. Has it been exploited in the last 24 hours? Has it been exploited ever? If it has been exploited, what is the remediation level, right? Remediation plan for it. So for example, if it's a vulnerability on Red Hat, or if it's a vulnerability on the kernel, has there been a fix available from Red Hat, or has there been a fix available for that particular vulnerability? So you take into consideration that. So in this case, you see the original score of the vulnerability was almost 9.9. You put in the factor, seems like it is also exploitable. Then you put in the temporal score, you see it's almost again 9.9, which is a high. It's a critical severity. But guess what? How does this vulnerability actually impacts your environment? In my environment, SSH might be disabled by default, right? So then this vulnerability doesn't apply to me at all. And at that point, so the environmental group metrics say that, how difficult, again, it goes through that entire loop of the attack vector and identifies how difficult it is to actually implement this particular vulnerability. So the challenge over here, as you see, is the context, right? I mean, this seems like a very manual process. What the challenge is over here is you don't want to have many false positives. You want to actually add more context to it. So imagine there is a tool. What the tool does is it tells it, gets information of your internal factors. It identifies how your use cases are, how your product is actually deployed. On that, it takes into consideration the external factors, factors like whether the vulnerability is exploitable, how far was it exploited, how is it, if it takes into consideration the external factors, then at that particular point you should be able to assess that particular vulnerability more true to what your or how it applies more. I mean, what I'm trying to say, it gives you a more true assessment of your product. So that is where AI can help, with the information that AI has. If AI can train on our data sets, learn the information that we have currently, not only on our internal data sets, but if it can help pool in the information that is even available externally, if it can look at exploitability information, if it can look at the probability of exploits, it can look at different tools, it can look at what the general community is saying about the information on the vulnerability. And with that assessment, and also based on your case, what are the versions that you're using, what are the mitigation steps that you have, so based on that information, if AI can help us actually identify the expert score for a vulnerability, then that would be a great assessment. So there are some companies already working in this space. You can of course use your day-to-day automation, but that is an area that will also see a lot of growth. So moving on to the next trends, right? I already spoke about AI. The challenges that we do see is real versus fake. And now because of the AI, though it can help us with vulnerability management, there are a lot of like increased exploits that you see. The other area that is also growing a lot of attention is the quantum computing and security. So you guys might be aware of RSA, or you guys might be aware of security or cryptographic algorithms that we use within our networks. Previously, these cryptographic algorithms were considered very difficult to break because the mathematical formulas behind it were very difficult to, like, for it was difficult to find two prime numbers. But with the advent of quantum cryptography or quantum computings, it is going to, I mean, no, we cannot, it will be very easy to break these algorithms. So the next trend is to actually look at post quantum cryptographies. How do you currently secure the existing environment, but also the future environments? And lastly, but not the least, as you see that there are many areas. Today, I have touched upon just you can say just a slice of network area, right? There are so many other areas that you can actually that open up opportunities. There are always dearth of skilled labor within, or like skilled professionals within security. So you typically have like security analysts, product security engineers, there's compliance engineers, there is bug bounty ethical hackers who are like constantly looking at the environment to check for any vulnerabilities that are present. And this can go from a legacy code like a BGP to anything that is new. And then also you have a lot of certifications that can help you get to the next level. But even if you don't want to go for certification, there is a lot, like tons and tons of security trainings that are available. So with that, I will summarize. And yeah, so that's pretty much what I had. Yeah, just the summary that I spoke about. That securing the SDLC will help you actually discover vulnerabilities early on. AI can provide you solutions for threat and vulnerability management, and the security domain is constantly looking for skilled professionals. I don't believe we have time for Q&A, but if you have any questions, feel free to send or email it to me or like add me on LinkedIn and ask those questions. So
Thank you so much, Manali, for your insightful session. I look forward to seeing how your career grows, and for everyone else